In the Turn Down the Heat report, we used the new generation of climate models, the so-called CMIP5, Climate Model into Comparison Generation 5 models, to project the consequences of two scenarios, a 2-degree world and a 4-degree world. And whilst the 4-degree world warms the planet roughly 4 degrees on average, the regional consequences of that warming are quite different. The climate models show that we expect the warming over land to be significantly greater than over the sea. So over much of Africa, for example, in a 4-degree world, we expect to see surface temperatures warming on average about 6 degrees, sometimes more. Over the last decades, we've observed a very significant increase in heat extremes, 10 times more area of the planet affected by heat extremes in the last 40 years, for example. We've also seen other kinds of effects on people. Obviously, heat waves and their effects are well known to nearly everyone who lives in a climate where you get them. Increases human deaths and mortality, has very bad effects on agriculture. But we've also seen other effects on economic development and growth, particularly in the poorest regions. In the last 30 to 40 years, there have been significant effects observed on the poorest developing countries from heat extremes that slowed down or set back their economic growth. So before we start looking at projections, we can already see from history that we could expect some consequences from increases in heat extremes. One of the consequences of global warming that scientists have known about for a long time is that average warming will increase the length, intensity and frequency of heat waves. And that's indeed what we see in the climate models. The new generation of climate models show an increase in all kinds of temperature extremes, unusual extremes, unprecedented extremes. Now, scientists refer to these in different ways. We use technical language, 3 sigma and 5 sigma. But the important thing to take away from that is that when we talk about these kind of extremes, we mean unusual ones and unprecedented ones. We're heading, in other words, into a climate that we've never experienced before, where the coolest summer months in the 2090s, at the end of this century, will be warmer than the warmest ones than we've experienced in recent decades, and probably over all of human history. When we look at the regional changes of heat extremes, we find some quite striking changes, and particularly we notice that the warmer the planet gets, the faster does the area of each region that we've studied get hotter. For example, sub-Saharan Africa, we see at present that unusual heat extremes are virtually absent. Around 1.5 degrees warming, unusual heat extremes cover 20 to 25% of the land area. By the time you get to 2 degrees, around 45%. By the time you get to 4 degrees, more than 85% of the land area of sub-Saharan Africa, for example, would regularly experience unusual heat extremes in summer. Southeast Asia, a similar picture, but this is a very tropical region where natural variability is very low. So what we see there is that with warming, the heat extremes become much more dominant faster. The small amount of warming leads to a larger increase in heat extremes in Southeast Asia. So that by 1.5 degrees warming, we see around half the land area of Southeast Asia regularly experiencing unusual heat extremes. By the time we get to 4 degrees, over 90% of the land area. South Asia is already quite a hot subcontinent. And we see a slower increase in heat extremes, but they still become very significant. By 1.5 degree warming, about 15% of the land area of South Asia is experiencing unusual heat extremes which are very uncommon now. By the time we get to 4 degrees warming, over 70% of the land area of South Asia is regularly experiencing unusual heat extremes. One of the clusters of risks that we see coming in sub-Saharan Africa due to the increasing temperature extremes combined with projected changes in rainfall over much of the region is increasing aridity. Aridity, if it increases, will affect and decrease livestock production and crop production throughout the region, creating risks to food security and people's livelihoods. Temperature extremes will tend to exacerbate the problem and be associated, at least according to our climate models, with increasing drought in the region. And these factors together will create major problems for people in terms of them being able to feed themselves and for the sustainability of societies in the region. The consequences of food insecurity, of people being unable to feed themselves, could be felt regionally with population migrations leading to regional security issues and possibly further afield. Unusual heat extremes, like the heat extremes we've seen in Europe, 2003, the Russian heat wave of 2010, the recent US heat waves, these we classify as unusual. They're one in many 100-year events that we wouldn't expect to see again in a stationary world, a world that is not being affected by climate change. But what we see coming out of the climate models with the heat extreme projections that we have are that these kind of heat extremes could become an every other year event in these regions within the next 70 to 80 years.